Assalamu alaikum warahmatullahi wabarakatuh. Welcome to module 6 of our course Microcontrolling Start as Professional. So as you see in this video, we are going to show one example how to use the AVR microcontroller to solve a simple problem related to input-output operations. So let's read the example question. Assume that PP2 is used to control an outdoor light and PP5 to control a light inside a building. If 1, which means high logic, light is on. If 0, light is off. PA3 is connected to light sensor, which gives 1 when daylight is shining and 0 at night. Write a program to turn on the outdoor light and indoor light when it is dark. Replace sensors with a button. Okay, so we have two lights. These two lights are controlled by two pins. The pins are PP2 and PP5. That means we are going to use port P, pin 2 and pin 5. If the logic on the pin is 1, that means the light should be on. If it's 0, the light is off. The input is coming from port A, PA3, so from the pin 3 of port A, and if the input is 0, that means it's night, that means the light should be on. If input is 1, that means it's daylight and there is no need for the lights inside the building, so it will be switched off. Okay, let's move now and have a look on the circuit. So as you can see, this is our AVR at Mega 32. We connect pin BA3 to a button. This will be our input, and we connect the port P pin 2 and 5 to two LEDs to represent the lights which we are going to be on and off according to the input. So if input is 0, it's connected to the ground, as you can see. So if the button is pushed, that means the input is 0 and the light should be on because it is night. If it's released, that means it will be 1 and the light no need to be opened. Of course, it's better to add a pull up resistor. So we add the pull up resistor, so like this we guarantee the input is always on unless we push the button. Let's move now to AVR Studio and start writing a program to solve this problem. So we start new project. We choose, as I told you, assembler, and we make a new project. We give it a name. So this is one example of the program that is going to solve this problem. So as you see, the first step we add here in the ASM file, we add the include m32a diff.inc. This is the header file that include all the information that is useful for us. One of them is the DDR. So as you see here, no need to write the address as explained in the lecture. We just need to write DDR and it will be replaced by the address because it's already stored inside the header file. Okay, now what we do in this program, we load FF, which means 1111 to register 20, and then we put them on DDRB. That means we define port B as output. Then we put 0 again on R20. Of course, we can use any register. It's just like a temporary register to move it later on to the port. So as you can see here, we put what is inside R20, which is 00 to DDR-A. So that now port A is input. So if all the pins of port B is output and all the pins of port A is input. Now we put here a label. This label will be used by rjump. So rjump is the instruction that jump to again. So as you see here, this is a loop. So rjump again, and here a label called again. Okay, so again and again. So from again we'll go back to here. So now what we are doing here, we use the command in from port B to R20. Again, R20 is just any of the registers. So you can use the same register, you can change register. So now we read what is on port B to register 20. Okay. Actually, why we read what is in port B? Because we want to know what is the situation of the pins of port E, that we need to know the situation of the output. If we want to read from the input, we use B in. Okay. So now this is the output. This is the input. Now we read the input from port A. because this is the sensor. Okay, port A is the sensor, as you remember in the circuit. Okay, so this is the circuit. BA3 is the input, so we read what is in port A. We can read only one pin, but it's okay, we read all the port. And this is port B for the output. Okay, now and I are 16 with 08. So what is 08? 08 is 0 0 0 0 1 0 0 0 0. So this is 0 1 2 3. So we want to make sure that all the inputs are 0 except the 1. Okay, so this is masking. We need to make all the pins 0 except pin BA3. If it's 0, all this, I mean in R16 will be 0. If it's 1, R16 will not be 0. Okay, so why? Because we want to use the jumping. As you remember, after this operation, if 0 in status register, Z will be 1 if it's equal to 0. Otherwise, it will continue to be 0. Okay, so we make benefit of this. Now, this update of the Z in status register will affect our choice here. So branch if equal and branch if not equal. Branch if equal is the comment checking the Z in status register. So branch if equal to on, branch if not equal to off. So now if it's equal to 0, that means this pin on port A is 0. So the result will be 0 in R16, and here will be equal to 0. So we will not jump to on. Now we made OR with 1 1. That means set pin 0 1 2 3 4 5. So pin 2 and pin 5 in port B will be set to 1. Okay, because we're making OR. Okay, now inside it all will be 0 except these two because they are originally 0. Then we move it to port B. So now we move, that means the pin 2 and pin 5 will be 1 and it will be on. If not equal to 0, we jump to off. Okay, so we skip this part and we jump to here, and now we make AND with this. So we set this the same two pins to 0. That means switch off the light. And again we put the value on port B and jump again to the place again to read again from port A. So if status is changed, it will be on or off according to the status of A. So this is the program. What we are going to do now is we build this program. Okay, as you see here, build is success. Now we move to the simulator and we want to upload the same program. Okay, so we go to the place where the program is stored. So this is one, and we take the hex value and upload it to our microcontroller in the simulation. We run the simulator. Okay, now you see the lights are on when I push, on when I release, off. Push, that means the sensor gives the value 0, so the lights will be on. When I release, it will be off. So like this we solve our example, and I will move now to the other camera and show you how to implement this in the hardware. Now I show you the implementation on the hardware. So as you see, first we connect the programmer to the PC. Okay, it's on. Then we need to connect the board to power. I click on the power. So now you see the programmer change to green and it's ready to program it. So what is our circuit? So as you see here, this is the programmer. Now I have pin BA3 connected through this black wire to, you see the black wire to K3, so button 3. Okay, also I connect A3, see here, A3 through a resistor to VCC. Okay, this is to make the pull up resistor. For the LEDs, you see I connect the 8 LEDs to the pins of port B, from P0 to BB7, BB0 to BB7. Now the program is already compiled because I use it in the simulator. It has no fail and it succeed. So we just go to make sure we choose the correct microcontroller and the correct device for programming. I come to AVR programming at Mega 32A, the correct programmer. Apply, ISP, read, voltage is okay. Then I go to memories and go where my hex file is generated. So this is my hex file in assembler 1. Open and program. Okay, now this is the circuit. So as you see, when I push button K3 which is representing the sensor, input is 0, the 2 LED will be on. I release off, and so on. Okay, thank you for listening and see you in next video.